So we're going to be talking about the first law for a mixing chamber. In this particular case, the mixing chamber is the open feed water heater, which I'm going to circle right now. Okay, so in the open feed water heater, let's go ahead and put in the first law. And this time I'm going to put in the summation. Because open feed water heater or a mixing chamber has a potential of multiple input and outputs. And I'm just going to add in the plus change of potential and kinetic energies. Again, we can assume those are equal to 0. For a mixing chamber, typically you don't see any paddle wheel, you don't see any electrical circuit in there. So there's no work done. We're going to assume that most of the mixing chamber are going to be well insulated or adiabatic. So the Q is going to 0. The conservation mass for the open chamber is such that mass in equal to mass out. And this is something that we have done during the first slide when we took care of the mass flow rate. But this is just for your information. So you have the two governing equations where the inlet and the outlet mass and enthalpies must be conserved. So in our particular case, if I were to look at my open feed water heater and to write my governing mass flow rate, I can then say what comes in must equal to what leaves. Oops, sorry, it should be 3. And m.2 H2 plus m.6 H6 must equal to what leaves as well. Therefore, I need my mass flow rate again. So here we go again. We've done this so many times. I hope you remember how to do it. 1 minus y. 1 minus y. This is still 1 minus y. 1, 1. Let's now go ahead and pop in what we know. 1 minus y, H2, H6, H3. Isn't it interesting? We now have one equation and one unknown. We can go ahead and solve for y. So you're wondering what is going to be your quiz question for Monday? This is going to be your quiz question for Monday. Analyzing the open feed water heater and solve for y.